The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. Alrighty, so today we're going to go on and take a look at section 8.5, but before we do that, are there any questions left over from last night's assignment that you would like to look at? If so, now is the time. Any questions?
No.
Alrighty, then we will go ahead and take a look at section 8.5. Oops, 8.5. Okay, so today we're going to be looking at solving absolute value equations. So first of all, let's review how an absolute value works. Absolute value is the distance between a number on the number line and 0 on the number line. So let's say we have 8 and -8, okay? The absolute value of 8, well, how far is it from 8 to 0 on the number line? It's 8 units. So the absolute value of 8 is 8. And we use two vertical bars to imply absolute value. How far is it from -8, whoops, to 0 on the number line? In other words, what is the absolute value of -8? That is also 8 units, okay? So distance is measured in positive units, not negative units, with one exception, and that is the absolute value of 0 is 0, which is still not a negative unit, but it's neither negative or positive. So absolute values are either positive or 0. All right, now, going back to this scenario, the absolute value of 8 equals 8, and the absolute value of -8 equals 8. So suppose we had the equation, the absolute value of x equals 8. Can you see from our examples that either x would have to equal 8 or x would equal -8? Because if we put either one of those in here and took its absolute value, we would get a +8 answer. So this equation has two solutions. Any questions on that? All right, let's say we had the absolute value of x equals 12. Well, then x could equal 12, or x could equal the opposite of 12, or -12, because either one of those values put in the place of x in the equation would give us a +12 as an answer. Any questions about that? We good to go? All right. Let's say we have the absolute value of x plus 3 equals 10. So that means that what's inside has to either equal 10 or what's inside has to equal the opposite of 10. Because if it equals 10, its absolute value is 10. If it equals -10, its absolute value is still 10. But now these equations aren't already solved for x. So let's go back and actually solve them for x. The first equation, if we subtract 3 from both sides, we get x equals 7. The second equation, if we subtract 3 from both sides, we get x equals -13. Let's go ahead and check our work. If we put that up here, we get the absolute value of 7 plus 3 is 10. The absolute value of 10 is 10. 10 equals 10. It checks. If we put this up there, we get the absolute value of -13 plus 3 is 10. The absolute value of -10 is 10. 10 equals 10, and that one also checks. So again, we have two equations produced, and then solving them, we end up with two solutions. Everything okay so far? All right, let's say we've got the absolute value of 2x minus 4 equals, let's say, 18. Okay, so that means that either 2x minus 4 equals 18, or 2x minus 4 could equal negative 18, or the opposite of 18. Again, solving each equation, the left equation will add 4 to both sides. 2x equals 22. Divide both sides by 2, x equals 11. The right equation, add 4 to both sides. 2x equals negative 14. Divide by 2, x equals negative 7. Let's check our work. If x is 11, we get the absolute value of 2 times 11 minus 4 equals 18. Well, 2 times 11 is 22, and 22 minus 4 is 18. So we get the absolute value of 18 equals 18. Therefore, 18 equals 18 and x equals 11 is a solution. Let's take x equals negative 7 and plug that into the original equation. We get the absolute value of 2 times, negative 7. Let's fix that. Okay. The absolute, let's see, 2 times negative 7 minus 4 equals 18. 2 times negative 7 is negative 14. Negative 14 minus 4 is negative 18. But the absolute value of negative 18 is 18. Once again, 18 equals 18, and the solution checks. All right. Now, let's say we have this situation. The absolute value of x plus 5 equals 0. Well, our first equation would be x plus 5 equals 0. Our second equation would be x plus 5 equals the opposite of 0. But 0 and the opposite of 0 are the same. So this would produce the same solution. So we really only have one equation to consider. And that is, we get a solution of x equals negative 5. Plugging that in, we get the absolute value of 0. 0 equals 0. All right. Any questions? Okay. Let's say we've got the absolute value of x plus 5 equals negative 10. Well, we would have x plus 5 equals negative 10, or x plus 5 equals the opposite of negative 10. On the left side of the equation, solving for x, we'll subtract 5 from both sides, and we get x equals negative 15. On the right side of the equation, we get x plus 5 equals the opposite of negative 10 would be positive 10. Then subtracting 5 from both sides, we get x equals 5. Let's go back and check our work. If x is negative 15, we get the absolute value of negative 15 plus 5 equals negative 10. Negative 15 plus 5 is negative 10. The absolute value of negative 10 is 10. So we get 10 equals negative 10. So that doesn't work. Let's check the other solution, x equals 5. Well, then we get the absolute value of 5 plus 5 equals negative 10. 5 plus 5 is 10. The absolute value of 10 is 10. 10 equals negative 10? No, it doesn't. So there's no solution. Now, at the very beginning of the problem, we could have determined there was no solution because, remember I said an absolute value has to either be positive or 0. So there's no way an absolute value could equal a negative number. What WebAssign will have you do, I believe, is in a situation like this, rather than writing no solution, they'll have you go through and find these two, what they call extraneous solutions. Then they'll ask you if they work or they don't work, and then you'll say that they don't work. Okay? All right. Now, let's say we've got something like this. 2 times the absolute value of x plus 5 minus 10 equals 40. Up until now, all of the equations that I gave you had a single absolute value on the left side of the equation with no extra numbers outside. Now we have extra numbers outside. We have a 2 multiplier or coefficient in the front and a term of -10 also. What we want to do before we do anything else, before we split it up into 2 possible equations, is we need to isolate the absolute value term. So the first thing I'm going to do here, I'm going to add 10. The next thing I'm going to do is divide by 2. Oops. So now I've got the absolute value of x plus 5 equals 25. So again, I've isolated the absolute value term. Now I can split it up and say x plus 5 equals 25, or x plus 5 equals -25, and then go on and solve both equations. To solve the equation on the left side, subtract 5, we get x equals 20. To solve it on the right side, subtract 5, and we get x equals -30. Okay, let's take this solution and plug it in. We get 2 times the absolute value of 20 plus 5 minus 10 equals 40, which is 2 times the absolute value of 25 minus 10 equals 40. Well, the absolute value of 25 is 25, so we get 2 times 25 minus 10 equals 40. 50 minus 10 equals 40. 40 equals 40, and x equals 20. Checks. All right, let's see. I now want to put in x equals -30. I think what I'm going to do is erase the work I just did in red there. So I'm going to wait a minute. Has everybody got that copy down that needs it? We good to go on?
Yes.
Okay, thank you. So now alrighty, we're going to say, oops, we're going to put the -30 in. So 2 times the absolute value of -30 plus 5 minus 10 equals 40. 2 times the absolute value of -25 minus 10 equals 40. 2 times, the absolute value of -25 is +25. So we get 50 minus 10 equals 40. And again, 40 equals 40. So both solutions check. All right, so let's review what we've looked at so far. If you have an absolute value set equal to a positive number, there are 2 equations that are produced. Go through and solve them, check your work. If you have an absolute value equal to 0, you only get 1 unique equation. So solve the equation and check your work. If you have an absolute value set equal to a negative number, you aren't going to get any solutions, but you could go through and solve it, get the possible solutions, and then check them and see that they don't work. If you have an equation that has not just an absolute value, but has other numbers involved on the same side of the equation, use the appropriate operations to get rid of them to where you've got just an absolute value equals a number, and then go from there. All right, there's one more possibility that may come up, and that is where you have, whoops, let's switch to black pen here. You have an absolute value equal to an absolute value. Now, we could go through and take what's inside and the opposite and all that and consider this. The absolute value of 8 equals the absolute value of 8. The absolute value of 8 equals the absolute value of -8. The absolute value of -8 equals the absolute value of 8. The absolute value of -8 equals the absolute value of -8. Huh? So you've got all these numbers in there, they're opposites, etc., etc. Well, let's go back If you didn't get all that written down, don't panic. So using that same idea, we could say what's inside of the left side equals what's inside of the right side. Or we could say what's inside on the left side equals the opposite of what's inside of the right side. Or we could say the opposite of what's inside on the left equals what's inside on the right. Or the opposite of what's inside on the left equals the opposite of what's inside on the right. So we get 4 equations. But upon further investigation, notice if we take this equation and we multiply both sides by -1, we get this 4th equation. So in fact, they are the same equation. Likewise, if we take this equation and we multiply both sides by -1, we get this equation. So in fact, there's really only 2 different unique equations. Okay, so once again, I'm going to go back and erase all this extra stuff. Actually, I'm going to erase it all and then, oops, something happened here. So I'm going to go back and just look at the 2 unique equations we'll get. So one of them would be what's inside equals what's inside. And the other one will take what's inside on one side equals the opposite of what's inside on the other. Okay, so we just get 2 unique equations. Solving the equation on the left, subtract 3x from both sides, add 7 to both sides, x equals -14. Solving the equation on the right, 4x minus 7 equals, we're going to distribute the negative sign, -3x plus 21. Then we'll add 3x to both sides of the equation. 7x minus 7 equals 21. We'll add 7 to both sides of the equation. 7x equals 28. We'll divide both sides by 7, x equals 4. All right, let's check those 2 answers. Let's take -14. We're going to get the absolute value of 4 times -14 minus 7 equals the absolute value of 3 times -14 minus 21. 4 times -14 is -56. -56 minus 7 is -63. The absolute value of -63 is 63. On the right side of that equation, 3 times -14 is -42. -42 minus 21 is -63. And the absolute value of -63 is 63. So the solution checks. All right, now we've got the other possibility, x equals 4. Let's see if I can do that up here. We'll get the absolute value of 4 times 4 minus 7 equals the absolute value of 3 times 4 minus 21. 4 times 4 is 16. 16 minus 7 is 9. The absolute value of 9 is 9. 3 times 4 is 12. 12 minus 21 is -9. The absolute value of -9 is 9. And it works, and I managed to shove it into that corner there. Okay. So if you've got a problem with just 2 absolute values, you want to have one on each side of the equal sign, and then you get the 2 possible equations. What's inside of the first equals what's inside of the second. What's inside of the first equals the opposite of what's inside of the second. When you take the opposite of, make sure you put parentheses around the whole thing and then distribute that negative sign. Okay. Any questions?
No.
Do you want any more examples of any of these?
No.
Anybody? Okay. Well, I know I kind of kicked it into high gear a day, but that's all I've got for you. So I'll be back at 1:15. I'm going to go ahead and stop the recording.